Hello, all being well, we are now live and we should be able to catch up with where we were up to. Hello, whoever we've got watching. Yeah, I'm hopeful that today we'll be able to get through a little bit of cleanup on the code and also trying to move us towards 64-bit compilation of it. So that'll be 64-bit compilation of the code, but we'll still be doing disassembly of 32-bit because this is only a 32-bit disassembler. But at least we'll show that a module can work. It should be quite easy, but we're going to just have to find out where we're up to. So where we were up to last time was I did a release of 0.6 with MRS and MSR working. That was all pretty fun. And yeah, we're going to have a look at where we were. So this is the main project. Oh, it's going to load. Oh, hang on. Yeah, give me a second. Yes, Google Chrome can connect to anything. My firewall's blocking me. Yeah. Any connection, please, allow. Oh, this is a good start, isn't it? Let's see if we can... just enable that. Yeah, I'm not sure why this is. I use Little Snitch as my firewall and protection system, and it seems to be decided. Oh, yeah, it seems to have decided that everything it's going to block right now, which is rather nice of it. You know what? Maybe I'll just. Come on. Maybe I'm going to have to just reboot the system. It's not actually working very well at the moment, which is just great. Good starting point. Okay, so I'm going to very, very quickly reboot and then we'll come back. So let's just give this a whirl and we'll see what we can do. All right. Okay. Back in a mo. Restart and yeah, okay, reboot. Hello again. Hopefully we're back. Sorry about that. Don't usually make mess ups like that and have to do things, but I did say to myself I should have rebooted, and then I thought, oh no, I'll be fine. I'll be fine. So that's on me. Well, obviously it's on me. It's my thing, isn't it? Not a big deal. Okay, I did a release, didn't I? Ah, I didn't make it. I didn't make it public. Oh, that was silly. Let's just go and make that one public. Oh. This release includes fixed support for the MSR and MRS instructions, which were not decoded properly. There we go. Right, so that can be in there, and that was released. Do it. Oh. All right, so we now got a release of that. That's all that really matters there. Okay, so as I was trying to say before we had a small interruption, we're going to try cleaning things up, and that's the doorbell. Of course, everything's happening at once. Give me a second. Back soon. I forgot to unmute myself. Right, okay, from this, let's get started. If we ever can get anything done, we're going to get some cleanup of the code. And I've now done the release, so that's okay. I have got a project in here that says things that need to be done. So this is my project for this. And we've got things like using debug error base, not the random one. Okay, that sounds sensible. Somebody suggested using different types for the instructions and addresses. That's a good idea, but we might leave that for now. It is an enhancement. Same goes for the IFR and DSR. So this is the instructions, ISFR and DFSR. That's not the right thing, is it? Instruction fault status register. Let's go and open that one and fix the text, because that's not right. Instruction fault status register and data fault status register. And those can be read from Sysinfo 7, apparently. And we could report those. It's not going to be very difficult to do, so we can do that. But we'll do that later, I think. Let's just save that one and close it. ARC64 disassembly, that's something we could do. That involves basically creating a new disassembler style for things, which is going to be a bit more involved. Debugger plus wise are going to be a bit more involved as well. Instruction comments on constant values, that sounds like an interesting one, but again, another enhancement thing. We don't currently decode floating point instructions. Now that's probably not too bad, but we're going to want to do that anyway, so that's something we should try and attack. And the new disassemble arc implementation, so we can do different architectures. Those are all good. One of the things I haven't got down in here is building in 64-bit at all. So let's see if we can, how do we add a new issue? Add item, that's what we do. Right, build module in RISC for RISC OS 64. Okay, so build a module for RISC OS 64. There we go. And then we'll just edit that one. Create new issue in this repository, yes. As a blank issue, yes. Okay, summary. We want to be able to use this module on a RISC OS 64-bit system. We should be able to compile and run it on 64-bit. So what do we need to do? Actions. We need to what do we need to do? We need to build it, and then we need to check that it works. I mean, really, there's not a lot else I can say on that. So let's we can have a look at that one, I suppose. Yeah, would also be good to ensure that it runs in the CI build system. Now, unfortunately, the CI build system currently doesn't run 64-bit code properly. It kind of works, but it's not completely working. And I was trying to get it working last night, but I didn't quite get there. So I need to do a re-release for that. So we'll have a go at that probably later in the week, and then maybe next week we'll add the build system for this. Okay, let's try and do some actual work, shall we? Debugger error base. Let's have a see this one, shall we? So we have a look in here. Oops, not that one. The CMHG file. Oh, is that big enough? I'm going to bump the text just a little bit bigger. Yeah, so I'm going to bump the text a little bit bigger. This will take a moment to actually do because there's a lot of windows that you can't see that are being resized as well. It's one limitation of Sublime Text, but not one that I'm going to worry about right now. There we go. Right, so that's a little bit bigger. Hopefully that's a bit more readable for people. Oh, it's still thinking. Come on, do your thinking. I'm kind of thinking maybe I should have just started the stream again, just like completely start from scratch, just to hope. But these are the trials and tribulations of not being prepared. Right, so what we got here, we got a SWI chunk of 14380. Is that right? That's the SWI chunk. So yes, error base is the wrong one, and this is using these messages here. Okay, so we need to actually look at the debugger itself and find out what errors it's got. Now, actually, the easiest thing to do is to have a look at what the error base would be for this. Can't start bad start memory syntax, start I syntax, dump I syntax. Those are all just bad command type messages, so probably aren't actually relevant. Is not memory A not interactive. No support for memory A interactive. Actually, I implemented that, didn't I? Didn't I? Let's have a see. In the veneer, memory I. That's the can't pass. That's not memory I meant memory A. Memory A. That's passing stuff. Interactive. Yeah, we get interactive stuff in here. So yes, we do handle this. We do a read line and things. So that's actually an unnecessary error message. We probably don't even have it. Memory A not interactive, isn't even supported, isn't even there. Gone. Right, so RISC OS kitten, header : new errors. So new errors is the file that's got error messages in it. So what I'm going to do is I'm going to search for the debugger in this. So debugger. Okay. Debugger, here we go. So breakpoint not found, invalid value, resetting breakpoint, no breakpoint set, bad breakpoint, undefined breakpoint, unaligned address, and no room for debug module workspace. So these are the errors, and they're at base of 800. So if we're going to use this, we've got to do it the same way. And the high level debugger is DDT. Oh, fair enough. Right, anyway, we need to rework these error messages here, because these are not the ones that it's actually expecting. Firstly, error base is 800. Hang on, how big was it as well? It's only 64 long. Okay, so I'm better leave a note actually. This is the standard debugger error base, 64 long. Okay, there we go. Right, so the error identifiers are these ones I copied from the other thing. So let's just make some of these look the same. So yeah, about that. Underscore break not found, brackets, and that's our oh that's not right, is it? Let's delete the spaces, brackets and commas. All right, so these are the standard errors that Debugger gives. Actually, you probably want to check that these are the same in RISC OS Open's version, because I'm only using mine. RISC OS is not, it's git.ris. gitlab.riscos, git.riscosopen.org. No, it must be GitLab then. I can never remember the URL, and it's there. We are right. Explore source. RISC OS. I want to look for. Oh no, I want to look for header source. There we go. Header source, header, new errors. There's new errors. I probably want to bump this text size up a little bit for you guys. Ooh, that's a little bit much. That's probably about right. Okay, so look for debugger. Debugger errors. There haven't been any new ones added, so we're looking good for this. Excellent. So Right, so that's all got those error messages. Now we've got ARM error messages at the bottom here. So what I'll do is I'll go and just make a little separation. So all of these error messages here are actually quite similar, aren't they? These are bad command error messages. And there's nothing, I can't give them a number that's from this lot because they're all the same. So let's see what we can do with this, shall we then? Cannot pass star memory here. Memory or memory I. Same message. Now, if I remember rightly, this is just bad commands. Or should it be syntax? It should probably be syntax, shouldn't it? So we go back here. Lots of syntax messages. Syntax, there we go. Is error number DC. So we'll make all of these DC. I mean, strictly, we could probably just put syntax error, but or bad parameters maybe. Well, this will do for now. Bad syntax for breakpoints. There we go. Not enough memory and no such break. No such breakpoint here is breakpoint not found. Breakpoint not found. So let's replace that one with break not found. Okay, so I need to find no such breakpoint, which is probably just in here. No such. No, it's not. Okay, well, in which case then, find it. No such breakpoint. In the breakpoints file. Oh, okay. No such breakpoint. Oh, what was the message again? I've already forgotten. Break not found. There we go. So I'll change it to that. So now we're using a standard error for that one. Actually, so a lot of these are related. Return underscore. Not enough memory. That's fair enough, yeah. Is that not enough memory? I cannot add. No room in breakpoint table. That's more appropriate, isn't it? When we allocate them as we go, we don't actually have a table of them in the same sort of way. Break not found. Oh, that's the one I had before. So there's only two in there. All right. So what are the other error messages? Bad breakpoint. When that's returned. We don't actually have very many. We'll look in here. So we've got cannot pass star memory I, cannot pass memory I. Bad syntax for init store is another cannot pass, cannot pass, cannot pass. And underscore break set goes into break set there. Breakpoint set. One interesting thing of this is that it's actually got, hang on, lost it, here we go. Missed, there we go. Unaligned address, which is actually relevant, isn't it? So not aligned is an error that we don't return at the moment. So we can do that. Should check it wasn't reused and check it isn't always breakpointed. Those are sensible things to do. If address times 3, return error not aligned. So now we're returning that one. Undefined breakpoint. Now I'm assuming that's on clear. Let's see if we can find where clear is. Here we are, clear. Break not found. Oh. Undefined breakpoint. Invalid value. Oh, invalid value could be what we're actually returning for these ones here. Actually, that probably is it, isn't it? These probably should be invalid value, not DC. Oh, that's irritating. How about we just edit all of those to be the same. And 801. There we go. Invalid value now has all of those error numbers. Well, invalid value is still 1, but all these are allocated as well. Resetting breakpoint. Ah, so if it already exists, it'll go and reset it. So I wonder why that's an error though, not a message. Breakpoint set. Clear. List. I'm not really sure. Let's go and have a quick look, shall we? Program. Oh, it's already in programmer. Debugger. Oh, they have C code in their version. Ew, that's quite nice. Exception handling. Yeah. Well, that'll make it easier for them to handle, except they have embedded great big chunks of code in there for no apparent reason. Well, not no apparent reason, but they shouldn't be doing it. This is their fun exception handling. Yeah, I don't do that. We do that elsewhere in select cache. VP. Fair enough. VFP processed instructions. I think we have a table for that. Right, let's have a see what we're doing here. In here will probably be where things are. So, which ones were the ones we were confused by? Undefined. Let's have a look for so it was called debug underscore undefined. Oh. Not in this file, in which case then it'd be in breakpoint handling. Not sure. Let's go for ARM. No. Let's try searching, I suppose. Debug undefined was the actual. Couldn't find any code matching. How odd. Make error. No. How about? Yeah, they've got loads of other things in here, but we're not supporting those at the moment. Somebody else can add those if they need them. So let's look at the breakpoint handling. Lots of swap all breakpoint. They do lots of mapping and things. Yeah, it's probably a lot more complicated if they're actually doing this the same way. Error debug no room. There we go. Bad breakpoint is there for break set. Error 1. Error 0 is break set error. Break set error is, the syntax message. No room. Can only set in the bottom 64 meg. Has to construct a branch. Oh dear. Well, that's that's unfortunate. So what? Oh, of course. Right, but this only applies to non-32-bit systems. It actually isn't true because the 26-bit OS can still handle breakpoints. There's the breakpoint instruction, which is how I do it here. How do we actually do this? Breakpoint instruction. Each code entry is 8 bytes too. Oh, this is all very weird, isn't it? They're actually making branches and other bits. Oh, how strange. Okay, so yeah, that's not done the same way, is basically the issue there. It's branch to debugger rather than what we do, which is breakput. And then we have an undefined a prefetch instruction handler that goes and traps it. Which is, yeah, just a different way of doing it. Break not found is if you try and clear something. That's fair, and that doesn't exist. Ooh. Clear all breakpoints. Oh, if you leave it empty, it goes and asks you if you want to clear all breakpoints. Let's try and do that then. We should probably do that. Clear. Where's clear gone? I've lost clear. Clear, here we are. Oh, that's actually the function for it. So it's command break clear. If argc equals 0, request to clear all breakpoints, clear a specific breakpoint. We can actually do that, can't we? There we are. Right, so clearing all breakpoints, we should have a clear function in this to basically shut it down at some point. Install prefetch handler, remove prefetch handler, annotate, find by instruction set, clear list. Ooh, we don't have one that removes. So when we shut down, do we leave all the breakpoints behind? Where's my finalization code? Initialization. Oh dear. Yeah, let's breakpoint underscore reset. Oh, and we want to, hang on, do we not? Install prefetch handler. I'm assuming we do that only once. Then remove it there. Remove the, yeah, if we remove all the breakpoints, then we've got that. So breakpoint clear is easy enough. Okay, so this is not actually that bad. Jump back to here. Breakpoint reset is what we want to do there. We go to the end of the code here, because this is an iterator through all of the values. Hi Dave, just seen you left me a message on the chat. We've had a bit of a fun morning so far. Reset, no, let's call this shutdown, actually would be better, wouldn't it? Final even, final. Finalize the breakpoint system, removing all handlers. We've got no parameters. Okay. And actually this, I don't want to iterate it this way. While breakpoint, whilst we have some breakpoints, we call breakpoint clear on breakpoints to address. No, actually. Yeah, that's right. We do it this way. Kernel os error equals if breakpoint equals BP. It didn't change. We need to return some sort of error. I'm just going to put an internal error message there, just to, so we've got something. I don't want us to return badly. This will never happen under normal circumstances anyway, so it shouldn't matter. Shouldn't. So we've got any errors for failing to remove it, and then at the ends, the handler should already have been removed. So that should all be good. All right, does that look sensible? So if we've returned it, we should do that there. Oh, the little check I did for alignment here should probably also be in here, shouldn't it? In the clear. I mean, that should never trigger either, but okay. There's a finalization call. We just need to put that into header now. Where's our header gone? Breakpoints. Spin to the end. And then the near is calling it. So, I've not built it for a little while. I probably ought to, oughtn't I? Discuss ammo. No, so many warnings. Finally ending up with illegal void object cannot pass start. Oh, that's all. Oh dear. I think something's gone screwy in CMunge. There's the file. I wonder if that extension line has confused it. Let's have a see. Oh, and 801. That doesn't look right. Go back to here. What do we do there? Oh dear. Oh, that got very nasty. I clearly didn't edit that right, did I? Maybe I wrote it wrong to begin with. Right, anyway, let's rebuild that. And we've got a build. Okay. Load module RM32, sorry, slash debugger. We're not 64 yet. I need the C library as well. Conlibs and GOS. Right. Oh. Command GOS. I should make that an actual switch. It'd be a whole lot easier. Right. So, break set on address 9000, please. Breakpoint set. Thank you. And then if I rm kill debugger. Except of course now I haven't got a debugger module to be able to see that. It's been reset, so I can repeat that process. Let's just get out again, try again. Basic. Right. Now address 9000 is that, so now set the breakpoint. Break set at 9000. Yeah, I'll look at that there. Memory eye it, I have to do that as well. Yeah, breakpoint number 1. And as you can see, it's also annotated what the old code was, which is pretty cool. And then if I go and kill the module, somewhere in my history, there we go, kill debugger, and then have a look at the address again. It's been reset back to being 0. Good. And presumably we've reset the prefetch handler as well, so that should all be okay. Right. So what have we done so far? I've done a couple of things here. I've changed some of the I've added the alignment stuff, I've updated the error messages, and oh, I've not done the implementation of clear all breakpoints yet. I was going to do that. Actually, that's the same as finalizing, isn't it? That's the same as finalizing. Yeah, let's just give that one a whirl, shall we? Right, before we do that, let's actually try and clean this up. So I think I've used smerge before. This is Sublime Merge. It's a way of handling Git changes without having to do like command line interactive things. So let's do the unaligned bits first. Actually, let's do the error blocks first, because the error blocks are the ones that are going to be relied on. So here we go. Error blocks added there, and these are all the error messages we've got here. So stage all of those. Okay. So git commit. I'll just show the changes. It's only those changes in there. Diff cached. So you can see that this is just the changes to the error identifiers. Git commit. Update the error numbers to match RISC OS classic debugger. Error number. Right, so that's that bit changed. Now what's next? We've got the module header in checked in. We shouldn't check that in. That file shouldn't be there. I think it's commit, yeah, remove erroneously added header with the CMHG file. It is in our git ignore, isn't it? It's not. Okay, it should be. h/modhead. Add git commit git ignore and amend to that, because that's part of the same change. There we go. Okay, where are we up to? So breakpoint finalization, we should add that in. So there's the finalization call in the veneer. Don't want that bit. Here's the header for it. Lines. That's the implementation. Stage lines. Don't do that yet. This one can be reworked. Yeah, all right, so there we go. Oh, I've forgotten what I did. Hang on, what do we have down here? Yeah. Add fix for failure to remove breakpoints on exit. Okay, so that's all right. And then we've got this error handling here. So unaligned address, not of memory, that's a different message. Yeah, we'll do that one. So this is about harmonizing the errors between the original. Okay. The error numbers and messages will be unaligned go. And finally, we can now get on with the implementation of clearing breakpoints. You done? Oh, golly. Well, that was tedious. So the next thing was, as I say, doing this clear, which I've lost. Here we go. Right. Request to clear all breakpoints. Now, if we go back to the actual code that we just saw over here, it actually does a nice was confirm and then acknowledge, which is, yeah, pretty neat actually. It means that things are a little bit easier for us. However, that means me actually calling os confirm and all that. Oh, that's how much hassle. So let's do that, but let's not try and be too clever about it. I'm just trying to remember if I've already got a little veneer for confirm. I think I have. I can't remember where. Cannot remember where. What would it be in? I don't know. Well, I guess we'll just create one. So let's. The easiest way to do this is just create a os confirm file. Os file. So this is all IO stuff. We don't care about that. I want os. Sorry, I was pointing to something you couldn't see. That's all the IO stuff. I'm going to create a new os.c file. Os interface veneers. Date today, 6th of July 2025. Include swize.h and os.h. Right. Os confirm. Oh dear, those were not the right letters. I think that's probably a reasonable interface for that. So let's correct the text. I'm clearly a little bit tired here. Oh, also escape. 4 minus 1 4. Is that sensible? No, let's. Response points to where to store y n 427. Turns into 2 error. Int star response. There we go. Confirm os confirm, it returns the value in R0, I believe. Response there. There we go. Yes, ensure that response ends up with, just in case anything gets assigned badly there. If error, return error. Otherwise, return null. Wow, that's pretty easy. The whole file, and copy the whole file, and we'll put it into here as os.h. If os. So this is how I usually do a lot of the SWI veneers, so that they're basically just a very simple veneer over the call. They could be replaced if we need to, so they're only doing one very simple job. It's not abstracted, but at least it's encoded in C, so we're not having to mess around too much. Where were we? os confirm. All right. So where's me thingy gone? My make file. Can't find the make file. That's gone at the top. This is probably just for the module, isn't it? This is going to be so we're going to want o.os. There we go. Build the code. Oh dear. Right. I'm going to try and start using the features that I've put in here. So I've got, oh, not that. Go back into OS again. Right. So I've got this set up so I can use a RISC OS build. There we go. So try building it. There's the thing. Lex storage class should have had it. Right. That's fair enough. And we can just make this a little bit bigger so we're not getting swamped by things. Include kernel.h in there. Expected a semicolon. Yeah, it's just because it got the wrong type. And then, yeah, so press F4 to go to the next error. SWI did not open, that's right, SWI's. And I think that should now build. So I'll just press Command B again to rebuild it. Undeclared name invent. Ah, right, okay, let's just include studlib. That'll pull in null. Okay, finished and built. So if that's the case, let's go back to our over here, pyro. Yeah, that one there. Oh, I haven't actually called it anywhere, have I? So that's not going to help. Let us actually do that. I have to implement code before it'll do things. Error may be used before being set. You're quite right. Request to quit. All right, so kernel os error confirm response equals equals 0, so it always gets something. If error, return it. If response is not equal to y, I think we should just return saying we're not going to do that then. Oh, so we ought to ask a question, oughtn't we? That would be useful, otherwise they don't know what we're doing. Printf clear all breakpoints. Should be that way around. Yeah, I think that's probably a good one. This is not equal to y. If they press escape, we'll just do a printf of escape. Otherwise, we'll print out the character because we won't actually have it. Sent C response. If it's not equal to Y, not clearing. Otherwise, breakpoint final, which will just clear them all and go. And then we can also return that because that returns an error. If it fails, we'll know about it. So build that. Inventing, that's because I forgot to include it, isn't it? Include or stage. Build. There's still some warnings in here, but I'm not going to worry because we'll come back and clean those up later. Okay, break set at 9,000. Break clear. Oh, I haven't left it the option of having 0 parameters. So in the module header here, let's have a see, where's the commands? Break clear is allowed to have 0 parameters. Let's just document that. Here's a breakpoint address. For if no, or all breakpoints if no parameter given. Okay. Build that. And then try running it. Set the breakpoints. Clear all breakpoints. Clear all breakpoints. Unfortunately, fortunately, depending on how you look at it, if you do os confirm in Pyromaniac, it pulls up this text-based thing because we don't have a pointer to do this, so we can actually do yes or no here. So do yes, and then it goes and prints out that. So I think that would work if we were in a natural environment. I can demonstrate that. I think. Let's have a see. Probably demonstrate. I don't actually remember how you do that. Pyrodev list config less. So something will handle os confirm. Confirm. Maybe I never implemented it. Oh, is it an implementation? List implementations, that's why. Yeah, os confirm can go through RISC OS. So let's do that. Launch it into WX widgets and implementation equals RISC OS. Dum dum dum. This is where I find it goes wrong. Double hyphen on WX. There we go. Here's RISC OS. So now if hang on. Yeah, we're stuck here because I've got the. When you launch it with WX widgets, it still has the read line using the host system. So input dot read line native read line. No, like that. Nope, it's readline native. Readline native, the other way around. Right, try again. There we go, you can tell it's working because you've got a cursor. So if we now go to break set at 9000 and then break clear. Huh. Well, that was interesting. It didn't. It said yes implicitly. Why did you do that? I don't know what that means. It means it's broken. I'm guessing I'll have to have a look into that. Annoying, isn't it? In which case, then let's use the WX widgets implementation. It'll look a little different, but we can at least demonstrate it in a different way. So, break set 9000, break clear, and we get a little error box that pops up that says, do you want to do this? It's not actually an error box, it's a native window. I can say yes to clearing them all. If I do break list, now they should all have gone. Break clear. No, not clearing. There we go. So something working, something not working. It's not a big deal, but that's now, we've now got that implemented, and that's good. So let's see what we've actually got there. Yeah, just a few files. Oh, and we need to add this OS as well. So look in there, and C/OS and H/OS as well. Commit those, commit everything. Added implementation of the star break clear for all breakpoints. Remove all the breakpoints that are present. There we go. There's also a break set that can take no parameters, it says there. I don't know what that does. Well, maybe it prompts you for it. I'm just not going to worry about that. Again, there are many little things that are probably not quite right, but I'm not going to worry on them. All right, so I'm kind of happy with that. I think that it's working okay. I've done most of the, sorry, some of the error messages that we needed to do, and I'm going to call that good enough, I think. So we are actually using the right error base. I think I can say that that is done. And if that's done, I can also push the code. So we'll have it up on the source repository. Right, it's very quiet on the chat today. Either nobody's paying so much attention, or I've not done anything wrong. I guess both could be true. Right, so the next thing I'm going to try is building for RISC OS 64. I'm going to start doing that, and then I'm going to do about half an hour of this, and then I'm going to have a short break, and then 10 minutes or so, and then we'll come back to it. We'll see how we get on. So most of our code here is okay, but there is a little bit of assembler, so we're going to hit some problems with this. But what I'm going to do is I'm going to build the library first, and then I'm going to try and get disfile working, because disfile is the demo. What does example do? Is example just a... I think example is probably the first one, so let's just build that. Let's go to amu -f makefile example. 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 What does it actually build? Oh, it calls it DARM. So example is just the very basic, we just try and call the library. So make the library work, make example work. In fact, these are stages, aren't they? So let's note them. Ooh, there's dots here now. Ooh, this is new. This wasn't here before. It must be part of the new pull request experience. So build library, build example code, and check works. Build dis file and check works. And then build module. And that's going to need remove the assembler to be done as well, and then okay. I don't think we're going to get the prefetch handler working because we have prefetch handling will be done very differently in 64-bit, so we won't be able to do breakpoints. Also, the breakpoint instruction will be completely different as well, so that's going to be a big difference to that. Maybe we can make it not do that in 64-bit right now. Yeah, we'll see whether that works. So let's suggest that. So disable breakpoint system in 64-bit and check that it works. Anything else? Yeah, that seems okay. All right. That's a pretty good set of instructions. One field with dis file, they missed the opportunity to have dat file. That was my name is dis file, so yes, I could have done that. Thank you, Chris. Right, let's go do some building. RISC OS ammo. File, make file lib. It's entirely possible that this is going to break badly and we're going to have problems, so let's just give it a whirl. Build it 64-bit. Okay, so code's building, and still building. We have a library. Interesting. 64. Yeah, we have some 64-bit code. Right. So, quick background to all of this. This is using my RISC OS build environment. RISC OS 64cc is a small wrapper on GCC, which uses the ARC64 version of GCC to build things. RISC OS 64 lib file is a similar wrapper around AR, but they're all using the same sort of file names that you'd sort of expect. So this one's actually using RISC OS file names, this one's using host file names, and it's converting them properly. So, knowing that that is the case, these files then are in the O directory, are not AOF files, they're ELF files. There is a RISC OS less, which uses some extra bits in there, so we can actually do O64/DARM, say, and have a look at, let's see, would it be CTZ? It's quite a small file, that I think, count trailing zeros. So this is the actual file here, and you can see that there's a bunch of symbols in it, and then we've got a disassembly that is showing disassembly of the ARC64 code, which is not very exciting, but well, there you go. I wonder if there's a count trailing zeros macro in this. Anyway, that doesn't matter. We can we can worry about that another time. It's an implementation detail. Okay, so I built the library. So we can go over here and we can tick built library. So let's try and build the example code. What was that called? Make file example? Yeah. Example. Dum dum dum. This is where we start to worry. Don't know how to make. That is because although I built the library, I didn't actually export it. And export headers as well. Yeah, there we go. All right, so now we can try building the library. Building the example code. The example code is built and it's linked it. And we can do the same we did before. We'll go and show what we've actually built. AI64/DARM-FF8. So here's our executable. And it's got a bunch of instructions at the top that look like ARM32 because we want to prevent it from running on old systems. But this is flagged as 64-bit. And there is a special instruction, a special entry point, sorry, at 100. So all of this here is actually just nop, branch to entry point. And the entry point is this code here, which then just causes an error to happen. It says the ARC64 binaries cannot be run on a 32-bit RISC OS. Not very exciting. And then the actual 32-bit code, 64-bit code starts at address 100, and it has a different AF header. So there's a 64-bit header, decompression code. That's a bug in my disassembler. That's actually meant to say relocation code, but it does go to relocation code, 0 init, and then branch entry point. And then finally, if you return from there, you get an exit. So here's the 0 init code that came from here. And if you look at the entry point, 8184, which is just down here, entry point code. And then we call off into main and do stuff. So it's the usual sort of thing you'd expect from code. There's nothing particularly especially exciting about it. It's just, yeah, 64-bit. So, having said it's just 64-bit, let's run it. Pyrodev in 64-bit, running the command af64.darm. And our example code works. It disassembles the 32-bit instruction. So, building example code and check that it works. Done. Next one, dis file, not dat file. Interestingly, we're returning code number 29 here. Is that normal? That might be a bug. Not sure. Pyrodev, just common. Run the old one, the 32-bit version. 32-bit version doesn't return an error. It doesn't return error code 29. Interesting. Let's have a look at, is it called example? Ah, right. That's because the example code's wrong. It should have a return 0 on the end of it. So if we just rebuild that, AMU example code, yeah, there we go. And then run it. Dum dum dum. No error. Thank you very much. It returned RC0. So next thing. If I'm confused, look back at my list. It's to build this file and check that it works. I've already forgotten what I was doing. RISC OS AMU for this file. Oh dear, yeah, this is breaking. So this is the default CPU registers. So this is the list of registers that would be used for showing breakpoints that we're not actually using in this code, but it's built into the code here because we call it. And it's just a bit of assembler. Default CPU register. If we have a look at it. Yeah. I really shouldn't have done it that way, should I? I should have done it as actual C code. So let's turn it into actual C code. You may as well. I mean, it's not a very nice structure regardless, but we can just make it a definition in C. So let's do that now. Touch C/default. Was it CPU reg? I think that's what it's called? And we'll start importing that. Come on, can I move that window down a little bit, please? You're just not going to let me, are you? There we are, picked it up. Go just down to there so I can see it a bit better. Default CPU regs. So, not a function, file. Default CPU regs. Return the standard CPU register table for ARM32. 6Y 225. Include default CPU regs. And there's a function declaration in there, a prototype, sorry, that I can probably have a look at. Oh, there isn't. That's odd. Oh well, we'll just copy the lot. Doesn't matter, we'll copy everything that's in here into the file. Into default CPU regs, paste. And then we'll just re-implement it. So this is actually, I need to also rename it as well because it was named wrongly. And this returns a void star 32 void. So if anyone hasn't been following this, the CPU register table is a table that describes where inside the breakpoint blocks, the dump of the registers, each register lives and how wide they are. It's documented on Pyromania. Ooh, can't spell. Under, let's find it in the PRM section. Oh, go away. PRM contents, hardware interfaces, program environment, I believe it is, describe CPU registers. So it's this function, OS platform features 64, describe CPU registers, and we return a static block describing the register layout. And the register layout has got an architecture format, number of registers, number of types of instructions. No. The lengths of the instructions that they can be, because for 64-bit ARM, it's also 32 bits, so instructions can be 4 bytes long always. But if you're using thumb, it could be 2 or 4. So there's a slight difference in there. We don't actually support thumb or x64 yet, but that's fine. And then there's a table that describes for each register where it lives in the table and where it lives in this table and where it is in the register dump, and then the type of register it is. So general purpose registers, stack registers, link registers, program counters, and then some flags. And then there's other types of registers, because other types of registers might exist. We might be including control registers in there as well, which would make things even more exciting. But at the moment, we're not doing that. This is it's needed in order for us to be able to describe programmatically what the register dump area looks like. And all we're going to do here is just return the table. Return default CPU regs 32, which we're going to define down here. So this is a uint 32t, an array of many things. And since we're doing it as a uint 32t, we need this to be it's also a constant one. A const. Need to include studint. Right, so all of this is in exactly the same format. I don't need that. So what I'm going to do is I'm going to do a line edit for every single line here. All right then. Sublime doesn't follow where you are as you're going up, and that might be a bug in the old version of Sublime Text that I've got here. I have to keep scrolling to follow all these. Actually, why am I doing this? Why don't I just select the whole thing? Because Sublime has another mode where you can just turn each one into a cursor. So each one of these wants to become OX there, have a comma on the end, and then we can just put a comment that says what this section here is. Oops. Like that. Excellent. And then we're done. And this block needs to go up before the others. Up here. I should probably declare it static as well because we don't want it actually exported, so only you could access it. There we are. And it should be called 32 as well. Dum dum dum. Alrighty. Now we don't have a declaration for this, so let's create a header for that called default CPU regs. There we are. Copy this whole file into the header. Delete all the actual declarations. And there we are. If nadef default CPU regs page. This isn't even going to be used in the just the disassembly part, so we're not going to care about that. But at least we can have it there. And if it will be used if we do show regs. So when we get to that point, it will be working. La la la. Oh, that's not actually documented properly in that, is it? Parameters none, returns pointer to the table. All right, and I'll just copy that into the other file as well, so we've got this consistent. I always try to keep the files consistent anyway. Right, so with that in place, I no longer need this S file, and I can so rm s/default CPU regs, and then we can rebuild it. And instead, it should build the C file. Oh dear. Well, this is irritating. Well, what I'm going to do is I'm going to go and do the build thing again, and I'm going to make it do the 64-bit build version, and I can jump. Ooh, bad file descriptor. That wasn't very happy. Do it again. Unknown command, what? I think I've got me arguments. Oh, maybe I can't do it this way. That's frustrating. Oh well, we won't worry about that then. We'll just do the builds in the terminal and edit them by hand. I've still got to get the integrations working properly here. Returning discards const qualifier from pointer target. True, it does. We need to go and make that have a pointer. And we probably ought to make it return it as, oh no, it's void star. That's going to be fine, isn't it? Thank you. Build it again. Okay. Oh, my kernel's failing to include the stdints. That's foolish. So this is that's a bug in my library. I'm going to have to swear at that, I think. But for now, what I can do is I can get away with that by doing in introspection here, we can just do, oh, we are including students. What? Oh, students. Oh, that's not, it's mine. So if def RISC OS 64 long. Actually, the long longs or the long ints? I think it should be long ints, shouldn't I? I think those actually should be long ints. It doesn't matter. We'll see what happens when we do this anyway. Oh, you have to actually change the code. Can I do like that? Because then it will go and bounce me off to the system defined one. And then only in the 32-bit version will it use this. Is that safe? Error, unknown type name. Trying to build C introspection. Included from Swise H from introspection C9. And introspection C line 9 is Swise. We've already included student. I think it's getting confused between those. I wonder if I can delete the student file, because I think I've already got one now. Oh, I'm going to do that. I'm going to delete student. It was only a transition whilst I was getting things working. Ooh, right. Just before I go and look at that, let's just check that we haven't broken it in 32-bit. I have. Introspection here. Default CPU registers 32. And we should be including default CPU reg.h. Let's just check that works. Qualifier losing implicit caster pointer. Losing the const is what it's saying. Yeah, that should be const really, shouldn't it? In all cases. Yeah, that's working. Good. All right, so go back to building the 64-bit version. And we got this error. So this is read escape state is failing because it doesn't have a flags. So in 64-bit RISC OS, no Swise return flags other than the V flag. And the reason for that is because it's insane. On some CPUs, some of those flags might not exist, or they might have different meanings. And it's just harder to work with. You would have to have special code to be able to handle the different cases that we're returning. So that's why I'm not going to do that. Instead, instead I'm going to go and just change the code to not do this. If we jump into read escape state, which is in the memory I, why have we got it directly embedded in the file? That's stupid, isn't it? So where was that? In our memory I. Here we are. So read escape. Oh, it is read escape state right there. It's in a, I've got a call here, so this is not too bad. But let's go and, before I do, let's jump over here and we can go into the PRMs again. And we will find interfaces for 64-bit, read escape state. So instead of returning the state saving processor flags, R0 will be set to the following values. So if def discuss 64. And yes, this is a little bit tedious, but it only needs to be written once. It should be if no-def RISC OS or something, I don't know. We should probably do it a negative, because we may have RISC OS AMD 64 in the future. Yeah, anyway, it doesn't matter. We're just going to turn this into 0. Still got it flags, but flags, if flags is set, we will return 1. And go for that. So that should now build. Cast from integers to different size block, well, fair enough. In this instance, it doesn't matter. But that is now built. We've now got a 64-bit binary. And the main problem we had there was I put some assembler code in explicitly, which was stupid. Dev 64 command af64.dis file. Right. Dum dum dum. Well, that looks pretty poor, doesn't it? It looks like I've forgotten to put the new lines on the end of things. It was working. It's built, but it's not very tidy. Let's just see if we ran the 32-bit version. Is it also broken in that? Or is this a breakage in the 64-bit port? No, it's just broken. So let's have a look at this file, which is this file here. Yeah, there. We've missed the /n's off the end of it. That's rather stupid, isn't it? Okay, so let's go back and build that again. Oh no, don't run it again. That's not going to do any good. Stop. Build it. And then run the 64-bit version, 64-bit. Right, okay, so we've got a choice. We can do dis file of a file name or dis file to dump a file. Fair enough, let's do the disassembly because that's the bit we care about. How was the file I was using? What were we using as our simple test? Hello world, that's right. So let's use hello world. Okay. Oh dear. That didn't work very well, did it? Okay. Well, I'm not sure what was happening there, but the initial part of this is disassembling okay. So I'm pretty happy. We've got SWI numbers coming out properly. We've got, yeah, pretty much doing the right thing. Obviously, this is disassembling a 32-bit binary on a 64-bit operating system, but not the 64-bit operating system it's using. Yeah, fair enough. I'm suspecting, if I have a look at this, we've got this here that's negative, a value 0 here. So it looks like we've got something pretty weird going on. What I am going to do, though, is build it for 32 bits and then see whether it breaks on there, because it might actually be a common problem with the two. Hang on, not that one. 32-bit run. 32-bit, there we go. Oh, that's printing the message out. Bum bum bum, hello world. Interesting. So we've got everything being assembled there, but when we looked at this one, it got as far as right 0 was not, and it's the not it's coming up with an exception on. Was not. So this instruction here, an RSB, oh, is it this one here, the raw 30? With the raw 30, oh, was it failed? Yeah, it failed on the actual not. Ooh, that's interesting. Those raws aren't coming out right. Because that's just saying raw when it should say raw R5, R1, 30. Whoa. So we are getting different behavior between the two. That's cool. All right, so this is going to be an interesting one to have a look at. In fact, probably the difference should be near nothing. But yeah, the raw. So all of these, what are they called? My brain has died. Shifts are not working properly, and it doesn't matter whether they're when they're registers, they're coming out with nothing, and when they're numbers, they're just dying. So that's quite interesting. So there's probably something common between these that's going wrong. And that's where it's dying. So what we're going to do is we're going to go back to the 64-bit run. What we're going to do is we're going to checkpoint where we're up to. C/default registers, H/default registers. Go. And if we can see here, we've got AF64, O64, OZ64s. Those need to be added to the git ignore. So AF64, O64, OZ64, and we will have an RM64 eventually. Okay. So what we've done then, we've got we've removed some of our assembler code, and we've made it build this file. Let's go on to commit that. All right, so initial 64-bit work, removed redundant assembler, added assembler, built example. This is the initial 64-bit version of the module of the disassembler. The library builds and the example program works. However, the dis file tool is showing up problems with the disassembly of some OR instructions. That's what we've done. We've got the old assembler code that embedded the CPU register definition for 30-bit is now gone. Now in C, the studint include locally is no longer needed, as even 32-bit environment as student. Okay, let's push that. Could have put that on a branch actually. I probably ought to have done, but for now it's fine. Right, it is now 2:45 and I'm going to go and take a short break. Does 2:45 mean that's been going for an hour and an hour and a quarter, hour and 3/4, doesn't it? Oh, but I lost a bunch of time because of the having to reboot and stuff. No problem. Okay, so let's have a break, and then I'll come back in about 10 minutes or so, hopefully, and we will continue looking at what's going wrong with this crash. Because otherwise things are okay, but I think we can get there. All right, see you in a little bit. Bye. Back soon. Hello, we're back. So, I'm trying to catch up where I was up to. So, what was I doing? I was in the process of trying to work out what was going wrong with this crash. We have a crash that happens in the 64-bit, but not the 32-bit. So, first thing I'm going to do is go and report what the bad output is. And then I'm going to go and report what the good output is. As I find the command. Did I just go past it? I probably did, didn't I? Yeah, there it is. Oh, excuse me, I'm sorry. Oh dear. And then we can compare the two. Bad against good. Right, here we are. This is what we've got. Okay. So yeah. Ooh, that address is wrong. That location has gone wrong. And that one as well. This is interesting. I wonder if that's not shifting properly. The difference between the things is that the addresses is that this one 1A and 1C, so it's only like what's this so the real one here, the good one is 1C, so that's 1, 2, 3 instructions. Now usually PC is +8 already, so it's looking like, is it just multiplying it by 2 rather than multiplying it by 4? Not sure. So we got a write 0 on that one, but it's written out write 0 on this one as well. It hasn't written out a new line, so it's looking like it hasn't populated one of the registers. So there's something going wrong there. One of the registers hasn't populated the SWI number properly. So that's interesting. And again here. So yeah, some interesting bits here. It's not just the bit that crashed. There's a bunch of other things going wrong. What should we start with? Should we start with the SWI call and see whether this is somehow broken? Because it could be my implementation of 64-bit stuff that's broken it. I will just make a point whilst I was doing this. So one of the things you can see here is that the processor state is being returned as 0 and it's returning a bunch of values here. That's because that part has not been decoded properly in RISC OS Pyromaniac yet. The CPSR state, or PSR state is in 64-bit. P state is actually what it calls it. Sorry, I apologise. Is just not decoded properly. Part of the point of this is that the CPU definitions that we were dealing with earlier, that should handle it, but I haven't got around to doing that in the Pyromaniac side yet. So this is actually not very helpful, but I will get around to doing that. It's just going to take me a little bit to get to that point. Regardless, that's not what's going wrong here. There's definitely something otherwise silly happening. Should we look at the exception first, or should we look at the SWI first? Yeah, let's have a look at the SVC first and see what the SVC is giving us, because that looks like it's probably going to be something that's a little bit more tractable since we know where that's coming out. So let's move this out of the way again. And we'll have a look at the SWI call. So is the SWI call being handled in Rodis? Is that where it goes? Yeah, this is where it's handled. This is the special bit. So we've got mnemonic here, and then we look up the immediate code. So have we got dprintf? We haven't. Oh, let's actually do this. Yeah, define debug. If def debug, define dprintf to be if one printf, else. Oops, that didn't copy properly. Copy, paste. 0. Okay, we've got. Right, we were down here. dprintf SWI lookup of number in. All right, let's see what we get out of that, shall we? I suspect this is a word length issue, but we'll find out. So let's do this. Yeah, we know what. RISC OS ammo make file dis file, and then if that was successful, do that, and don't put it out to good, just put it there. We build it and then we run it. So here we go. It is printing out SWI lookup of and the numbers. So 32-bit coming out fine. Do the same for the 64-bit version. RISC OS make file dis file and there. Oh, sorry, and then build it 64-bit as well. There we go. So on this one, lookup of number 2. Ooh. Well, that's interesting. That implies that it's not actually getting the right SWI number. Oh, maybe decode SWI isn't working. That would be embarrassing, wouldn't it? That would be very embarrassing. Let's have a see, shall we? Because yeah, that isn't doing the right thing. Lookup SWI goes to, is it in here? Yeah, lookup SWI. So SWI number to string. Well, that looks like it should be doing the right thing. In fact, I think that ought to be doing the right thing. Let's have a see, shall we? Right, so config SWI traps equals, what was it called? So I've forgotten the SWI name already. That's SWI. Oh, no, that's not right. Trace.SWI traps. I've got to give it the module name it's in. There we go. We'll debug all of these SWI calls. Right. I might need a bit more room for this. So, here's one of the calls. Lookup of number 2. Number 2? No, this isn't SWI number 2, is it? This has got a silly number. Is everyone looking up number 2? Oh, everyone's looking up number 2. That's why it's coming out with the wrong things. Wonder why it's got 2 in there all the time. Well, let's trace this backwards, I suppose. That was a foolish thing to do, because we don't actually have So this one, yes, it's looking at number 2, but then subsequently, all the others, so this one should be SWI number 3, and it's looking up 2 again. Okay. Oh dear. Mid. 64. And export it. Just check we have exported it properly. It has been exported. Okay, get rid of that file, we don't need it anymore. It's no longer used. Right, so we need to find out where dim is being set for that SWI, because that's not working. It's actually an SVC call, so if we look for SVC in here, check if the highest bit of 24 is set. If so, we manually extend the integer on this SVC. Oh no, if it's not an SVC, sorry. You can go into this one, should it? In fact, I wouldn't have thought it would go into this particular function. That's the only place it's dealing with an SVC instruction. Lots of these are all marked as SVC because obviously, yes, they are. It's a big chunk of the address space. So C is the, I don't know what those are. Let's go back into the parser, shall we? What's in here? It's condition, yeah, of course, everything's got condition code on it, and then I is the integer. Interesting. So it looks that by the time it hits here, it's probably been set to, im has been set to that. It looks therefore like that is the place where it's going to set it. Let's get some debugging in. Why not? Sorry, no. This is in. It says that it's not. Ooh. Right. tarm brnchsc branch /SWI. I think that's all what it's actually doing here. And this is w equals cent x, and what's bit mask? I don't know what bit mask is. Bit mask 24. Just make sure that they actually have the values we think they are. This is a little bit tacky as debugging goes, but not a terrible thing. It'd be nice if I could do breakpoints here, wouldn't it? One day I'll get that sorted. Yeah, W and bit mask 24. Okay, let's build that and see what happens. Build the library. Build this file. I don't need to track the SWIs because that's not actually the problem now. Okay. That worked without crashing. What did I do there? How have I changed it? It's now giving me undefined instructions and branch misc and all sorts of things. What's going on? Oh, this is not very nice, is it? Did I change more code than I thought I did? No. I did not. What? I'm just going to comment that out again and see what happens. Just give me a moment. Oh, it's in the library, isn't it? Sorry. Build the library first. Now I'm getting completely different results. I'm going to delete all of the object files and start that again. Just because I'm confused now. So if I've done this right, all of this stuff should be in build /export libdarm o. Yeah, there's the export. And then build it again with the disfile tool. Rebuilding all of that code. Not many warnings, not ones that will be relevant either. And now I'm back to where I was. And it's not crashing. Build library. I'm going to say I don't know what happened then, because that was odd. But also these SWIs are coming out right now. In fact, it's all coming out correct. Comment out the debug here. Rebuild the library. Rebuild this file. Did I have some junk lying around from previous build or something? I think it's possible. This was the bad one. Okay. Pull this up here. Left file has changed. Exactly the same now. Okay, spooky, don't understand why. Gonna set it aside for the moment. Maybe I'll review the video later and see if I missed something. Yeah, I might do that. Okay, but important part of that is this file now works. This file, not that file, which is cool. So that can go down there again. Go over here. And actually, we haven't changed anything. I can just take that code out because that's not relevant. We don't want to pollute the original source code. So this file is working. Next, we need to go and try building the module. So we'll do that, I guess. First thing to do is to remove the assembler. Well, we've removed the assembler already, partially removed the assembler. There's a second piece of assembler here, which is the prefetch handler. And none of this is going to work because of how we... all of these things are happening completely different ways on 64-bit, and they're not properly implemented in RISC OS Pyromaniac yet. Just because trying to get everything working before we can before I can do anything is silly. I've just got to stage things in a useful way. So prefetch handlers, you can't do that just yet. So can't re-implement this. What I can do though is tell it that I don't want to build it. So if we go back to the make file for the module here. That's not very tidy. Let's just tidy this up. Just got tabs and places and things. There we go. It's the prefetch handler here, isn't it? So if nadef, build 64, only when we're not building 64-bit will we do this. We might have a prefetch handler in there. Fair enough. And if I go back to the module header, we can put an error in this, can't we? Add a new error message, just so we've got one. Not supported. I think there's actually an error code for not supported. I have a feeling there is. New error, there are new errors. Supported. Oh, there isn't a not supported error in there. Implemented. Support. Oh, well, we don't have a standard number for that, so I'm going to just create a new error on here. Does not support breakpoints in RISC OS 64. Okay, just for this, we'll label it as not supported 64 because then it can be isolated to just the 64-bit things. I think that's a good idea. Bum, bum, bum. Right, and then all of our veneer code that does break all of these things here, we can go if def RISC OS 64 return not supported 64. Else break clear as well, and that'll just get us to the point where we've actually got something working anyway. Looks like value there isn't actually used. Value. Scope of value can be reduced. Well, that's true, it can. But actually, I could reduce it, couldn't I? Don't do drive-bys. Only fix the thing you're trying to fix at a given time. Otherwise you get yourself confused. Show regs we can have. Command debug. This is part of the handling for breakpoints. So we can get rid of that as well. Same goes for continue here. And everything else is good. Righty. Let's do the building of a module. Build module and then try and load it. Load module rm64/debugger, FA, and then command GOS. Drop to command line. It's unlikely we'll actually get it built to begin with, so we'll just try and get things working first. Got a couple of warnings there from those casts, but that's not terrible. Error, undeclared error. Near 486. Line 486. Oh, I did this a little bit short. Should have been down here. Okay, no big deal. Still got problems. Find me an error. Come on. Oh. Read line, read line. Right, again, read line flags implemented differently. What file was that in? In Veneer, okay. So read line. Okay. Yeah, there's a read line function here. Yes, there's a special readline function that tries 32-bit, then goes and tries the 26-bit version, and of course that's different than in the 64-bit version, because of course it is. Right, okay. I have a Veneer for readline in one of the modules I did recently. Come on, where was it? I don't know. I wish my errors could be fixed by changing no code, says Alan. That's, yes, I wish they could as well, but not all of them are just commenting things out. Right, I can't remember which module I had done this readline in. So what I'm going to do is it was definitely one of the 64-bit modules I was creating. So let's go and have a look at my status page and we will see where it was. So it was one of these modules had it in, I thought. File types, module commands, OS commands. Readline obviously implements it. Oh, maybe I didn't. Maybe I didn't. None of these look like they've got any input in them. PyroDev GOS. What module commands? What does module commands have in it? Nothing that would do any input. OS commands? Do any of those take input? No. No, none of those take input either. So why would I have implemented it recently? Something that was reading a line. Oh! The C library! Of course, the C library would have implemented it because it's in fgetS. So in RISC OS 64 simple binaries. That's on GitHub. github.com/Gerph/ just got simple binaries. clib in the filing system code. No, not filing system, the IO code. fgetS. There we go, os readline. That's an implementation of os readline. Fortunately, I can just pick the whole thing up and it falls back in the same way. I have a feeling this was actually pinched from the same place. So there's my code. Copy it into, so I can just copy it into here in the veneer, which I could do, but actually I think it would be better to copy it into the os functions in here, because it makes more sense to have it separated. So just to be clear for this one, if we go back to here, so this is the Pyromaniac PRM readline. Here we go, os readline. Oh, I should also document this as os readline 32 as well. Does not return the escape state and the processor flags, and instead it's returned in R0. So if we're running in 32-bit, we just return R0 and sorry, in 64-bit, we return R0 and R1. And if we're doing this the other way, we go and do it this way around. We keep the readline 32 interface exactly the same. And the flags just end up being handled in a very similar way. It's just the how things are indicated is slightly different. In theory, some of that could be common. Line red, that bit could be common as well. But it's not a big deal either way. So that is the os readline function. We can pick this up and put it into here. So we've got a declaration, a prototype for it. Yeah, that's happy now. And then if we go back to veneer, instead of having this here, because it's exactly the same interface, we can delete this code and we can just make readline call os readline. There. Is that the only time we call it? Oh no, we've got one down here in debug as well. Although we're not using debug, we can at least replace it. There we go. So that's in memory A. We do that. Okay. Build it again. Label escape used but not defined. Bother. That probably means I didn't copy enough code. I didn't copy enough code. Idiot. So Icon Bar described this as seeing an expert at work or something like that. It's like, no, you get to see somebody who makes really dumb mistakes. Right, so this is the breakpoints file. Oh, right. So in breakpoints, it tries to do the prefetch handler. Now, strictly, we don't even need the breakpoints file because it's not going to do anything. Probably the easiest thing to do here is just to make all of the file vanish, except the finalization code. So we do endif there, and at the beginning we do don't even need that. If def, if not def, it's got 64. None of this breakpoint code works on SCOS 64 yet. I'm not sure I'm going to get around to doing this in this example and live coding thing, but for now we just make the module work is what the point is. As we call it, we do breakpoint annotate, and we've got breakpoint clear. Oh, and of course we can't clear anything because the breakpoints aren't even present. So in finalize, there's just nothing to do. If not def 64, if yeah, too many letters there, and if yeah, that looks okay. So it's going to be just dead function. It doesn't do anything. And the other problem was, oh, annotate. Yes, we need to just stop it doing the annotate in the memory A, which is down here somewhere, isn't it? Annotate. Yeah, I'm going to be lazy. If def is 64, no, there's no annotations present. Otherwise, there are annotations present. And just to try and keep myself sane, I will make it only the parameter, not the structure that goes inside the conditional. And we have a debugger module. Modules. Help debugger. Okay. Break clear should give me an error. Does not support breakpoints. Awesome. Star memory of 8000. Have we broken the general behavior? Nope, that's working. Memory I 8000. That's true, they are undefined instructions. Dump I hello world. It's gone back to doing these undefined instructions again. Oh, this is silly. I'm not really sure what's going wrong here. This is very odd. In fact, those are garbage. It's returning pointers to invalid memory even. That's very weird, isn't it? That's very, very weird. Modules. Why are we going slowly now? Star modules, help debugger, make clear, did some disassembly, this. Star modules. Star modules is implemented in module commands. Module commands is implemented in Python. So this shouldn't be going slowly at all. Apparently I didn't put a escape check in the star modules code. That's irritating. It makes me think that we've got some extra debug enabled. Pyromaniac debug. Are there any debug flags set? No, but everything's going slow. Stop. Let's kill that. processor load. Yeah, not stupid. I mean, high, but not silly. Mostly it's OBS, you see, because it's doing its encoding for this stream. But the rest of it, yeah, not too terrible. Okay, this is definitely some sort of pyro problem, I think. Modules. Help debugger. That was the command I did, and then I did modules. Still was okay. Break clear. Does not what. Can I install modules? What do we do then? Memory 8000 plus 4. Modules. Just 8000. Oh no! I wonder if it's turned on the printer. No, it hasn't. It could be. Echo 2, sorry, modules. There you go, it's turned on the printer. And the reason this goes slow is because every single call has to go through the full VDU vector, and it actually slows everything down hugely than doing it as a stream of data. So that was what was going on. Interesting. Yeah, I can't do anything about that. I've considered on many occasions that if you're in the WX version, the desktop version of Pyromaniac, it should pop up a new window that's showing you what's being sent to the printer whenever you start writing output to the printer. It's a bit of overkill, but I think it'd be quite fun. Right, so that's what's going wrong at the moment, but it's unclear why, because that disassembly should be working. I mean, it's not like there's anything particularly difficult going on here, unless, no, I don't think that breakpoint annotation is going to have made any difference, is it? Is it? Disassemble memory is in Rodis. Where's the annotator guy? Annotate. Disassemble memory. Oh, it's not in there. Is it in memory I? It's in memory I. So we pass in the annotator function. So disassemble stuff. And disassemble stuff is this one here. That's dump stuff, sorry. This is disassemble stuff. Where's my annotator? Annotator. If we have an annotator, then we printf that. We call disassemble word. Disassemble word reports stuff. Returns a pointer. Is that a pointer to the stack maybe? Maybe I've done something stupid like that. That would be weird, but it's possible. And disassemble word is in here. Static char buffer. So that's not on the stack. Let's just do it this way just to see what we're getting out of it. Now I really want to do interposition so we can actually go trap this, and then when it returns, do this other thing. But I haven't got around to doing that yet. It'd be really useful as debugger. That's in Rodis. Is Rodis part of the module or part of the library? It's part of the module, that's good. So, memory I, modules, memory I 9026004. So this will disassemble parts of the debugger. Decoded OK, but returned with undefined instruction. And now it's fallen apart because of the printer being turned on. Darmstra, that's the thing that actually makes us a string. Oh, yeah, it should be. That's what we should do, isn't it? Deprintf. So we do a swine lookup. That's the end of the string. It's possible I may have to look into this offline because it's. I think this might actually be a linking problem. Something between the library and the actual code. I mean, how it's linked it together and done the relocations. It's possible that my relocations have become broken. Yeah, that's died again. And it does say returning with decoded. Did I not build that? Decoded OK, and then returning with. So Darmstra 2 is not recognizing it. That's interesting, isn't it? That is quite interesting. There's Darmstra. It calls Darmstra and says, yeah, I can't do it. You know what? I'm going to go and try this a different way. Okay. Yeah, right, okay. Pyromaniac debug trace. Get ready for some heavy nastiness. 3. 1 instruction. Whee! Okay, so it's doing a lot of stuff. Maybe I should have piped this to a file. Yeah, almost certainly I should. Let's stop that. That's it, copying undefined instruction. Okay. There we go. Right, let's go back to that command again. Change it to memory I 903.1234, and then pipe that all to trace.txt. Also, only turn boot debug, only turn the debug on once it is booted. How about we only disassemble one instruction as well? Go. This may take a moment or two, obviously, because it was spewing out loads of stuff. Oh. And of course it comes out on standard error. I really need to fix these dumps of the processor state because they're not useful to me. They're just plain wrong. Internally inside Pyromaniac, it goes and munges all of the 64-bit state into a 32-bit type state. So all of the cases where we go, oh, switch mode to this, work properly, or at least work how they used to. That's not how you'll do it in a regular system, but right, there we go, we've got that. So let's now go and have a look at the trace file. This is going to be huge. Parse architecture, yeah, I don't care about that. This is just basically trying to work out what it's got. I'm going to look for the first darmstra function. Here we go, so we're going to darmstra 2. Ooh, wow, we take a long time to get into there. Really? All the rest of the time we're doing other things. Okay, that's actually quite impressive. The scroll bar here is way down the bottom. Well, 3/4 of the way down at least. And as we saw, darmstra 2 calls into darmstra, goes and does some stuff. Name. Reads it out of a table. What's the betting that that address doesn't actually contain the table? Let's have a look, shall we? I could do this, reload it again, because all the addresses will be consistent. So I can now go and, oh, yeah, that's interesting. I just have to do start memory. That address, please. Yeah, that doesn't look like a table of text. Although it does kind of look like a table of pointers to text. Oh, but they're way too low. They're in application space if they're pointers. That implies that my relocation isn't working. In fact, this actually looks like a relocation table. This looks like the actual relocation table to me. Oh, can we? Yeah. That still looks like the same sort of thing. 3E. Well, that's interesting. That looks like a table of characters, which it actually could be. It could just be a table of characters. We do have a table of characters. Yeah, that's interesting. Because that's going to be the C types table, you see. That's a function name. 9 C, please. No, now we're into this table again. I would say that looks very much like a relocation table, though. Right. DOS boot debug trace. Load. I'm 64 dot debugger. Yeah, this is the relocation code, and that's the relocation table. It's obviously a lot here, but yeah, we start off, we call clib initialize module, and then we go straight into relocation code here, which apparently I've got wrong because this is not correct. Is very, very much not correct. So here we've got addresses that are looking right. Address spaces. Maybe those should have been the same bit. I don't know. I need to check how my relocation code works. I can't remember. Yeah, these addresses here are looking realistic. These ones, however, are the source. That's the relocation location, the place in the table, not the thing it's pointing to. Yeah, I'm definitely going to have to look at this offline because it's not a problem with the debugger. It's a problem with my relocation building. So what happens is we build code in ELF format as object files, and then we do some post-processing to add in a relocation table that can be used in a module. Even though I'm not handling the case of module instantiation, I've still got a relocation to do because it's now at a different place in memory and we're not loading ELF files directly. So, because a module isn't an ELF file. We could do that in the future. We could actually have an ELF file in the future, but we haven't done it just yet. So consequently, this table that's built up contains lots of information about where things are in memory. If we have a look in this, so over here, this is the C simple binaries. This is the relocation table generator, and it uses the symbol table and the map to generate some relocation table inside there. So in the table we were looking at, where was the table? Sorry, let me just find that memory I statement. Not that one. That one there. Oh, of course, I've got debugging turned on, so it's actually trying to disassemble things. This one here, please. So the thing that I said was a big relocation table, which is this block here. What you can see in here is a number of entries that are 2 with data area relocation. Whoops, go away. Data area relocation, and then addresses. So this is one address to get in 8 bytes, and this is another address. So this wants to go here. And I think what I've done is I've gone, this needs to go here, literally here in this location. The code we generate is this relocation table here, and this is the assembler code that does it. So presumably, yeah, I'm gonna have to reread this code carefully. So this is read a pair of registers, that's this one here, here, and here, into there. R7 is the place that we're referring to, and R6 is that. So my phone's blipping away. Oh well. Yeah, so I'm going to have to look at this separately. Again, anybody wanting to have a look at the way that this works can have a see at it. It's pretty tacky. I will admit it's very, very tacky in places, but that's how it runs within the system. I've definitely had this relocation table working. I've definitely got it working because I've been using it for some of the more complicated things I've been doing. So I guess I'm probably broken it recently. No matter. So I'm going to call it a day there, because that's not a problem that is related to the debugger itself. It is related to the 64-bit environment. If we have a look at the things we've changed, we've got a number of things here that are pending, just to separate it out so that the module can build, and we don't have breakpoints present. What I'm going to do is I'm going to go and commit that as is. Actually, no, I'm not, because I think there's some bits that are wrong. There's some bits in. Is there some bits in the actual? No, it's all in my code, so this is not too bad. But I probably should turn off the debug, so that if it's built, it'll have a working version module. So we just jump into here and turn off debug. Oh, it's not on there. Rodis. Here, turn that debug off. Right. So, oh, hang on, there's a bit missing. Is that everything? Yeah, it's everything. Commit my A. Right, so updated module code to be able to run 64-bit without breakpoints. Breakpoints are turned off as they require a prefetch handler to work. No, we don't have one in RISC OS 64 yet. Present, the build is working, but the disassembly is failing. Static tables are not being relocated properly. So I'm going to have to look into that separately. What I can do though is go back to here and say we've removed the assembler, we've disabled the breakpoint system, and it doesn't work. So I will look at that later. Hi Andrew. Andrew Ronsley's just turned up, and I'm just finishing up for the day. The summary is, with some problems with rebooting early on, being delayed because of that, we have now managed to make most of the system build 64-bit. The module builds, it just doesn't work. It generates invalid disassemblies, and that's because, or what it looks like it's because, is the relocation code that I've got inside the module linkage is breaking, and I need to look at that outside of this session because it's part of the 64-bit build environment. But the command line versions work, so let's just push that as well. We can now do disfile. So I didn't want to do that. I wanted to disfile hello world. World. So that's not spelt right either. There we go. Is that going to work? Yeah, so that's the 32-bit version. That's got a little bit of debug in it at the moment. And the 64-bit version is even more noisy. So we just make the 64-bit. There. Come on. There we go. 64-bit version running. Right, I'm going to go and call that a day. Thank you very much for joining, and sorry you overslept, Andrew. The video is available to all to watch, and I will re-mention the 64-bit status pages. So if you go to RISC OS 64 status, it's got a status of things that I and other people are working on. I am only going by what has been updated in the 64-bit forum posts. There's a lot of modules that are not done. There's some that have been started by me, and there's many that are not working. A lot of binaries that are working as well. Oh, that's not come out right. I'll go back to that later. Right, you can watch the video again, as I say. So have a good afternoon. I think the thunderstorms here are finished, so hopefully the rest of the day will be quite nice. See you all later. Bye. I should have some sign-out music when I play something else. Maybe at some other point. All right. See ya.